Hello, good morning. I'm trying to see if I can see everybody in here. Give me a sec. All right, and as you join, if you want to tell me where you're coming from. All right, so we're going to wait a little bit, just a few minutes, and then we're going to go ahead and get started. Go ahead and introduce myself real quick. My name is Kyle O'Malley. I am a community development manager up in the north. And today we're going to be going over coding basics, which is a part of the Senior Coding for Good curriculum. Oh, Richmond, Virginia, really cool. All right. And I'm going to try to respond to people. It's going to be kind of hard because I have a couple screens up, but I'm going to try to intermittently answer any questions you all have. Texas, South Carolina, wow. Very cool. Okay, let's wait. Wait another minute, and then we're going to go ahead and get started, and people can pop in whenever they can. North Carolina, South, got both Carolinas, very cool. Cincinnati, awesome. Las Vegas, very cool. All kinds of parts of the country. All right, let's go ahead and get started. So to reiterate, we're going to be going over coding basics. We're going to be doing steps 1 through 4 here, and then I'm going to leave you with an activity to do for step 5, but I'm going to talk to you about how to do it. So I'm going to be going back and forth between talking to you and showing you my screen. So let's get started with step 1. Step 1 is going to be using functions to create a self-portrait. And that sounds super intimidating, but it's really not, because we're going to be going over what functions are and how computers read them. So essentially what a function is it's a chore. Functions are a part of algorithms. So you've probably heard algorithm before. What an algorithm is it is a set of chores that you give a computer to do. So, think of, you got to clean the house. That would be like an algorithm. You're telling the computer you got to clean the house, and the function is the things you have to do to clean the house. So to clean the house, you gotta make the bed, you've got to vacuum the floor, you've got to dust furniture, you've got to clean the kitchen. Those are the functions. So it's a specific task that you're telling a computer to do. And it's, if you think about when you make a bed, you don't think about the things you do to make a bed. So you have to teach a computer to do that. So if you taught a computer how to make a bed, you would teach it to put the sheets on, you would teach it to fluff the pillows, to fold the blanket over at the top when you're done. Things that we don't think about because we do them every day, but computers don't make beds unless you tell them to. So that's why we have to teach them how to do it. And let's look at what functions look like. So I'm going to go ahead and share my screen real quick. And we're going to type out some functions and talk about what they are. Now, these are just going to be ones we make up. We're not going to write entire functions because we don't have enough time to do that right now. But let's make some functions. So we talked about making a bed. So I'm going to do this how you would do it in Java. So in Java, you always make the last word capital and you can't use any spaces. So if I was going to make a function for my computer to make a bed, it would probably look something like this. Make bed. You want it to be something that you remember. because, if all you're doing is making a bed, that's super easy to remember. But when you get into a whole program and now you've got an entire house to clean, and then now you've got several houses to clean, you want to make sure that it's as easy to remember as possible. So think of other things that you would do when cleaning your house. So you'd make your bed. That's an easy one. You vacuum the floor. And then make sure you put these parentheses at the end. You can write this out, or you can do it on a computer, whatever you prefer. Since we're not doing like the whole program, we're just kind of brainstorming and talking about how you make programs. You can do whatever you want. Other ones, feed pet. And you can do feed cat, you can do feed dog. I'm going to do feed pet, and we're going to talk about why later. And then for my last one, let's do dust furniture. Okay, cool. So like I talked about before, oh, my screen isn't sharing. Okay. Oh, 1 second. Okay, sorry. We're going to go back through this. Okay. Okay, sorry about that, everybody. I'm going to go through it all again. It's really easy, though. Okay, so if we were to make a function to make your bed, it would probably look something like this. Like I was saying earlier, you want to make it something you remember. And for some reason in JavaScript, you always make the last word big. I don't know why. That's just how it is. I'm sure there's a reason for it, but I don't know what it is right now. So we did make bed, vacuum floor, and then make sure you put the parentheses at the end. And we talked about feeding a pet and dusting furniture. Now I'm just going to go ahead and keep sharing my screen for a second since it's being goofy. Cool. So now that we've done that, that's how you would, clean a house. This is teaching your computer all of the things to clean a house so that you don't have to teach it every time. Like, could you imagine if you had to learn how to make your bed every single time you made it? That'd be awful. You learn it and then you just do it. And that's essentially what we're doing here. So let's think of that in how you would describe a face to a computer. When we draw a face, it's easy. You draw the outside of the face, you draw the eyes, the ear. But a computer doesn't know what a face looks like until you tell what it looks like. So think about what kind of functions you would want to teach a computer to do. So you'd probably want to do something like draw the eye. You need 2 eyes, so I'd probably make one for each eye. And I'm going to put first eye. You might want to put left eye or right eye, but you've got to remember that computers don't know the difference because they only think literally. And there's actually a word for that. So the way that computers use language is called syntax. So if you think of, let's make the font bigger. Oh, no, not that. Let's just zoom in. There. Okay, so if you think of the way that you talk and the way you use tone and grammar, that's kind of what syntax is for a computer. So if you've ever heard like syntax error, that's a computer's way of saying that you use the wrong word, that like it doesn't understand what you're saying. So think of like if somebody ever said something and maybe you didn't know the word they used. That's kind of what a syntax error would be. So syntax is grammar for computers. But let's see. So we probably draw a mouth, and think of the other things you would use to draw a face. And then while you're doing that, think about what it would be like if this is how we talk to people. What would be the pros and cons of if we all talk to people like computers? Some pros might be it'd be efficient. We'd probably get more things done. But what are the cons of it? It'd probably be a little weird, Okay. I'm gonna try to share myself again. Hopefully it works. Okay, hopefully that font size is a little better for everyone too. Okay, so the next thing we're going to do is we're going to kind of move further on that. We're going to write code to create a portrait. And what that means is we've made functions, and now we can use those functions to get more direct with what we want to do. So we're going to use something called an argument. And an argument sounds bad in the way that we talk about it day to day, but when it comes to programming, arguments aren't bad at all. Arguments are something you give to a function to give it more direction on what to do. So we used the example of making a bed earlier. If you know how to make a bed, then you could use that same function to make, your bed, to make your siblings' bed, to make your parents' bed, depending on how nice you're feeling that day. And that's what an argument is going to be. And I'm going to show you how to do that real quick. So let's switch back to my screen. Sorry, I'm going to have to switch to this for a sec. Okay. So earlier, we put these parentheses, and I talked about making sure you do that. And here's why. So in these functions, we're going to put our arguments. So we're making a bed. And in here, you can put my bed, and then you can put, and you can put spaces here. These are things that you named, and they can have, let's put an underscore, just because that makes me feel better. You could put parents' bed, and like I said, we're feeling real nice, siblings' bed. And you can do, so what this is saying is you're telling the computer, okay, I need you to make all the beds in the house. What does that look like? I need you to go, and I need you to make my bed. And then when you're done with that, I want you to make my parents' bed. And then when you're done with that, I want you to make my siblings' bed. And there's other things you can do too. So in this case, it's what? But you can also do descriptions. So if you make functions, you can get really crafty with this stuff. So let's go down here to our self-portrait, since that's what we're doing here. Anyway, so it works out. So drawing your first eye. So what are some, I would think adjectives in this case, or where you want it to be. So like computers thinking like X and Y coordinates. Like think of how you would draw a graph. Where would you want it to be? But we don't need to get that complicated with it. So just think of like, what color would you make it? So we make it blue. Could make it big, small. I'm just going to put medium. And that would be an argument here too. So we're telling it that I want you to draw the first eye, and I want it to be blue, and I want it to be a medium size. These are really generic because it's just something we're making right now, but you get the idea. Hair, using one, blonde, and then maybe you want to put a length. And then maybe you have some other descriptions you want to tell a computer how to draw on a face too, like maybe you have freckles, or you want to put dimples, or you want to put like, ears. I would say that's probably a good thing to put on a face that you might not think about immediately. Okay. I'm going to switch it back. All right, so that was step 2. For step 3, we're going to be learning about computer logic. And what computer logic is just the way that computers do things. So like we said earlier, when you make a bed, you're probably not thinking to yourself, I got to put the sheets on, I got to do all this. You just do it because it's what you do. You're used to it. But we have to teach computers to think like us, or think like a computer, really whichever way you want to put it. Same difference. But so what we're going to do is we're going to talk about control flow. And that's how computers work. Computers think from the first thing you tell them to the last thing you tell them. So you start at the beginning, you go through a bunch of tasks, and then you end up at the end. And the example I'm going to use is making a s'more. Because, with everybody being trapped inside, I'm excited to start camping again and go make some s'mores when all this is done. So let's make some logic s'mores. And you can do this on just a piece of paper. We're going to make a flow chart. But I'm going to do it on my computer because if I try to draw, you guys have to see my handwriting, and nobody wants that. So think of what goes into making a s'more. So when you make a s'more, what's the first thing you need? The first thing I think of is graham crackers. Because you can have everything to make a s'more, but if you don't have graham crackers, you don't have a s'more. And then what's the next thing you need? You would need marshmallow. Can't have s'more without marshmallow. And then I'm going to do chocolate. I'd say these are the 3 things you need. But there's other things you need too, like you need a bonfire, or at least some type of fire, and you need a stick to put the marshmallow on to heat it, right? So if you were a computer, what you would do, and you say you were looking to make graham crackers, what you're probably going to do is you're going to check and you're going to see if you have graham crackers. So we're going to make a control flow here. So let's say we have graham crackers. Awesome. Doesn't matter. Move on. We're gonna check for the next thing. That's ideal. Let's say we have marshmallows. Awesome. We're gonna move on. And we're gonna get chocolate. But what happens if we don't have graham crackers? If you were a computer, you wouldn't skip the graham crackers and say, all right, I don't have graham crackers. I'm just going to get marshmallows. If you're a computer, you've told it, don't go until you have graham crackers. So what a computer's going to do is you have to tell it, hey, if you don't have graham crackers, I need you to keep checking for graham crackers. You need to go get graham crackers. And you can do that through different ways. You can just keep telling it to check for graham crackers, or you can make a separate function to go get graham crackers. So this is saying we have graham crackers. Awesome, cool, let's move on. But if not, we gotta get those graham crackers. And we're gonna do that the whole way around. And this one I'm making is really simple. Control flow you can get super complicated with, but we're gonna keep it simple. And then let me do this one. And if you want to use what I'm using right now, it's actually free. It's called Lucidchart. You just have to make an account, but paper's fine too. Probably a little bit easier for you. So this is an idea what that looks like, and let me show you. I have a completed one right here. So this is what a computer, if you were to teach a computer, think like a computer, how a computer would make s'mores. This is what it would check for. It would check for graham crackers, marshmallows, chocolate, bonfire, and a stick. And once it had all that, it would say, awesome, we can make s'mores. I'm good to move forward with this. All right, switch it back for a second. Okay, cool. So next, we're going to talk about, for step 4, if statements. So an if statement is an example of Boolean logic. And what Boolean logic is basically how computers make decisions. So when you're making decisions, you know, we just kind of go through with it. We know what we're doing. Computers don't know that, so they use Boolean logic. They say, is this true? Yes. Then okay, then I'm going to do this. But if not, then they're going to do something else. So that's kind of what we did with that control flow there. We told it, you know, to check for marshmallows, chocolate, and move on. And once it had everything, it can make s'mores. So let's write out what that looks like. Okay. And I'm going to zoom in a little bit more, just because. All right. So let's think of what we have right here. We have the graham crackers, and then we're checking to see if we have them, and if we have them, we're getting marshmallows. So what an if statement looks like is, it's usually, in almost every language, just the word if. And then let's just name it graham cracker equals true. So what we're doing here is we're telling the computer, make sure there's a graham cracker. And if there is, then we're going to check marshmallow. Now that's awesome. We told it to check the marshmallow, but what happens if there isn't a graham cracker? Well, that's where an else statement comes in. So if there's a graham cracker, we're going to check for marshmallows. But if not, we've got to get that graham cracker. And you can do this on the whole thing. So, and this is kind of what makes functions too, is they're just full of logic like this. If you think about how you do something, and what kind of decisions do you make to do that? So now we're going to check for, we're going to check for the marshmallows. But if not, we're going to go back to the marshmallow. And you can do this with anything, really. Anything you could think of, you could probably turn into, not probably, you can turn into Boolean logic. Might take a little bit of crafty thinking, but everything you use, this is what makes it run at the end of the day. There's obviously a lot of other stuff, but the root of all of it is Boolean logic. All right, and then once we have this, then make s'mores. So what we did here is we took that control flow and we went from top to bottom and we did all of the things that we would do, that we would check before making s'mores. And that's how a computer's going to think. Computers are extremely literal. Like I said, they only do what you tell them, which is great, but when you can't make things work, the frustrating thing is it's your fault. So, but the good news is, we can always fix our mistakes. So, all right, and that is step 4. That's exploring if statements. So I'm going to switch back to me. So this last step, this is going to be something for your girls to do at home. This is going to be using everything we learned today. We talked about functions, we talked about algorithms, we talked about arguments and how they make functions easier and more exact. It tells the functions what to do. We talked about control flow, and we talked about conditional logic using if and else statements to think like a computer. So we're going to use that knowledge, or they're going to use that knowledge to do step 5, which is making a quiz show using true and false statements. So what you do when you make a program is you make a flow chart just like that. Like Lucidchart is a really good one for it. And you think about what you want the outcome to look like, and how you get to where you need to. So think about what kind of questions would you ask on a quiz show. Think about things like, if they get an answer right, do they get a point? What does that look like? Do they need a certain number of points to win? Can they get anything wrong? Do they get a different answer based on if they got the first one wrong or right? And those are the kinds of things you're going to want to think about in making a quiz game show. All right. I would love to see what those look like. Just to go over what we did today, we went over coding basic steps 1 through 4 from Senior Coding for Good. We used functions to create a self-portrait. We wrote code to create a self-portrait using arguments. We learned about computer logic and did control flow and talked about what that looks like. We used if and else statements to think like a computer and learn how computers manage tasks from start to finish. And finally, step 5, we'll be making a quiz show using that logic, using everything we learned. So if you liked this or interested in this, definitely go to gsw.org/join if you want to be a Girl Scout and do more stuff like this. There's all kinds of cool stuff we do. Have a great weekend. I really appreciate you all tuning in, and I hope that you make some cool game shows.